Friends, in this class we are going to end our electrical windings. In previous classes we have discussed various types of electrical windings, AC as well as DC windings. Before going to study our three-phase wave winding, let us recollect what we have seen previous classes at a glance. This is one electrical machine which consists of armature coils. You can see how it is size, how it is a big size. Okay. At the same time, so let us recollect. First we have studied DC machine windings. So in DC machines we have seen that the armature consists of a rotor part along with commutator on which the brushes, whereas stator has the concentrating winding poles. In armature we distributed as per full pitched coils as per our requirement based on the number of poles, at the same time full pitch coils. So in that case we have already drawn single layer and double layer lap winding and wave winding. And comparing to the DC, so AC machines plays a vital role in our society. Let us see what are those AC motors. So types of AC motors you can see here. This is a one single phase motor. You can observe this type of the motor in our laboratory. This is also, and this can be used for to attach the pumps. This is a three-phase induction motor. You can observe this type of the motors used in agriculture pump sets. And these are the different type of the machines for the different applications. Why should prefer the AC motors as compared to the DC motors? As we know that while both AC and DC motors serve the same function of converting electrical energy into mechanical energy, they are powered, constructed and controlled with different techniques. The most basic difference is the power source. AC motors are powered from alternating current, while DC motors are powered from the direct DC sources such as batteries, DC power supplies, or we can use the rectifiers. It converts the AC to DC. The DC wound field motors are constructed with the brushes and a commutator which add to the maintenance, limit the speed also, and usually reduce the life expectancy of brushed DC motors. Nowadays we are using the brushless DC motors also, BLDC motors also. AC induction motors do not use the brushes. They are very rugged and have a long life expectancies. The final basic difference is speed control. The speed of DC motors is controlled by varying the armature windings current, while the speed on AC motors is controlled by varying the frequency. As we know that the frequency, the speed N is directly proportional to the 120 F by P. Here the speed is directly proportional to the frequency. At the same time we can change the speed also with the help of the number of poles. So as comparing to the so many objectives, so AC motors are user friendly, rugged and cheap and best as compared to the DC motors. Hence, we are studying the different types of AC motors, whether single phase motors, capacitor start motor, split phase motors, shaded pole motors, and etc. etc. And coming to the three phase motors, that may be induction motors, squirrel cage induction motor, slip ring induction motors. At the same time, the asynchronous synchronous motors. In synchronous motor also our AC motors. In last class we have seen, so single phase the windings, okay, AC windings. We have seen what is the lap winding in case of the single phase and what is the wave winding, how we are going to draw these windings, wave winding and lap winding in AC machines we have seen. Biggest induction motor. This is the stator part, this is the rotor part. Stator part consists of armature here, okay. Rotor maybe it consists of squirrel cage rotor. In previous classes we preferred single phase motors, but comparing to the single phase motors, our three phase motors has more flexibility and uses. The single phase alternating current is the most common source of power used by most households and non-industrial businesses, as you know. The three phase AC motors is particularly common in large business, including in the manufacturing and industrial business areas. The efficiency of three phase operated devices and appliances is higher than the single phase operated machines. Hence, so three phase machines are less costly and more efficient comparing to the single phase motors. Hence, we should know, so what are the different types of the three phase motors, how its armature is owned in the armature. Okay, so you can see this is a one figure. Let us see few more figures. So you can see this is the one synchronous machine. It consists of rotor as a concentrating winding, poles, and where is the armature is a stator part. You can observe this type of the synchronous machines are used in power generating plants, hydropower plants, thermal power plants, etc. Now, let us compare AC motors and DC motors. Already we have seen. So, AC motors are user friendly, whereas the DC motors has the commutator, brushes. Due to this one, there is a speed control is only through the armature control. At the same time, speed also limited. Otherwise, there is a spark may be occurred on the armature commutator segments. Whereas in AC motors, no problem. Our armature is stationary part. So, it is easy to wound. There is no insulation problem also. Okay. So, that is why most of the industries preferred AC motors. Motors also. Here, so how the windings are distributed. You can see this is a one of the armature, this is the another armature, and these are the different armatures generally used in our electrical fields. How the windings are distributed, you can see here, and two pole winding and slotless winding also we can see the bottom figure, and concentrated winding you can see how this winding is concentrated for the pole purposes, and distributed winding you can see here how the winding is distributed in full pitched coils or short pitched coils to develop the rotating magnetic field. And you can see the slats of our armature core also, you can see it. Okay, these are poles and how the pole shoe, how the winding for the concentrated winding, you can see here. Okay. At the same time, you should know what is a concentrated winding, what is a distributed winding. This is a concentrated winding, this is a distributed winding. Let us see. Now, this is a three-phase concentrated winding. The phase 1, phase 2, phase 3. The windings are placed in such a way manner. It connected these are all coils in such a way. Whereas distributed winding, you can see these windings are distributed in a full pitched coil with the help of the back pitch and front pitch, you can see. Okay. Generally, the concentrated windings are used in three-phase transformers where there is no rotating magnetic field is developed. Whereas in motors, we required three-phase distributed winding with full pitched, with pole pitch, with full pitched coils. Sometimes we can use the short pitched coils also. What is a short pitched also? We have already learned in previous classes. Here distributed winding means is a same winding. So phase 1, you can say black one is the one phase, and ash one is another phase, and orange one is another phase, placed at a distributed slots based on our back pitch and front pitch with one pole pitch apart. Okay. So we discussed this also in previous classes. Now let us concentrate how the three-phase winding distributed in a two-pole machine and four-pole machine of a AC motor. Okay. Let us see. Now we can see here one, how the conductors are distributed in a given armature slots. Here let us assume the armature is stationary part. It consists of, let us assume slots are 1, 2, 1, 2, 3. So 12 slots, you can see here. Poles are 2 poles, three-phase winding. Now, so here you can see a red color is a one phase, and yellow color is another phase, green color is another phase. So these windings produces these fluxes in a systematic way. So that's why it, whenever the three-phase supply is given to these terminals, it induces a rotating magnetic field at a magnitude of phi r at the time of 1.5 times of maximum flux produced by any one flux, rotating at a speed of n is equal to 120 f by n, that is the p, that is at a synchronous speed. Now at the same time the slots also divided based on the number of poles. So you can see, so this is a very important, dear students. Here m is the number of slots per pole per phase. So the total number of slots is a 12 here, divided by number of poles, 2 poles, and phases, 3 phases, 3 ones are, 3 fours are, 2 ones are, 2 twos are. That means, so 2 slots per pole per phase. That's why, so here, so whatever the, that means the pole, north pole and south poles. So total 12 slots divided by 2 poles, that means 6 slots under north pole, 6 slots under south pole. Under north pole, you can see here this 6 slots further divided into 2 slots for R phase, 2 slots for Y phase, 2 slots for B phase. Such a manner it is distributed. Okay. So let us see another P is equal 4. So in this case number of poles are 4. So let us calculate what is the M. M same here also, same thing. Okay. What is the M? So 24 by 4 into 3. So same, we are going to get the 2. That means under north pole The 4 poles you can see here. So, North Pole, South Pole, North Pole and South Pole. Okay. So, that means the each pole consists divided by the how many slots. So, here total 24 by 4, that means 6 slots. So, that means under North Pole 6 slots is here N1. So, 2 slots for R phase, 2 slots for Y phase, 2 slots for B phase. Similarly, so all slots are distributed equally under other North Pole, South Pole, North Poles. Okay. So, this already we discussed with help of one story in previous classes. Okay. Now, let us recollect what is the wave winding. Now, what is the wave winding? Dear students, we have drawn so many wave windings. DC wave winding, AC wave winding, single phase wave winding. Okay. Now, let us see an armature winding in which the coils are laid in 2 layers and follow each other on the surface of the armature in the form of waves, with the coils being so connected in series that there are only 2 paths for the flow of current, whatever the number of poles in the machine. Okay. So, in wave winding already we discussed. So, what is happened? Here is a one coil, and this coil is placed, first coil is placed under the North Pole, and second coil side is placed on the South Pole, and another coil I am going to connect. So, another pole pitch. So, another coil is connected here. So, this is a coil 1, coil 2, this is also placed under the North Pole, this is a North Pole, and this pole is connected on the South Pole. That means here this is a back pitch and this is the front pitch. So, just like it is a wave, and already we know that in wave winding all number of parallel paths are 2 independent of number of poles. That means, so this wave winding can be used where we require the high voltage, low current required. Okay. So, the basic things already you know. Let us take one key problem. So, case study. So, where we will take the machine as a 4 poles, conductors or slots or 24 slots, wave winding in progress wave winding. We are assuming the progressive instead of retrogressive, and wave winding, and conductors are 24, slots also 24. So, each slot consists of one coil site. Okay. So, let us do that problem. So, as usual for development of simple wave winding, so what are the steps is required? Simple calculation for pole, what is the pole pitch, what is the back pitch, what is the front pitch is required. After knowing the back pitch and front pitch, we are going to make it the winding table diagram. In this case, in 3 phase, so in addition to the winding table, we require the conductor distributed table also is required to avoid any confusion. What is the distribution? Conductor distribution table, last class we have seen, here also we are going to see it. Okay. The third step, after knowing the winding table and the conductor distribution table, so we are going to connect end connections with the help of this table information. That is develop the winding diagram with the help of the winding table. That is a finish work. Okay. So, these are the steps, simple steps to complete our case study. Okay. So, what are the calculations, what are the salient points regarding to the wave winding in AC? So, as usual, so back pitch is equal to the pole pitch we are assuming, and back pitch and front pitch are equal, and the resultant pitch is equal to, in this case, the back pitch plus front pitch. Okay. Now, take the one problem. So, that is the problem is, what is the problem? So, here the problem is the question P is equal to 4 Conductors are 24, 3-phase, wave winding, progressive winding. Let us do the calculations. So, what are the calculations? Let us see. Conductors is 24, 3-phase, wave winding, progressive winding. Now, first you calculate the what is the pole pitch. Okay. So, then what is the pole pitch? The pole pitch is equal to, so total number of conductors by number of poles, that is equal to 24 divided by, so 4 pole machine, 4 ones are 4 6. So, we are going to get the 6 is the pole pitch. That means each pole influenced 6 slots, 6 conductors. Okay. Now, after knowing this one, then what is the M? So, what is the M? Small m is equal to number of slots for poles per phase. So, because it is 3-phase. Now, total slots is 24 divided by number of poles is 4 poles, okay, into phases are 3-phase. Okay. 3 ones are 3 8s are 4 ones are 4 2s are. That means 2 m is equal to 2. Okay. So, that means total slots per pole per phase. So, under the influence of north pole, for example, 1 pole, so that means here 2 conductors for 1 phase, 2 conductors for another phase, 2 conductors for another phase. For example, R phase, Y phase, B phase. So, these 6 conductors influence of north pole. Similarly, under south pole also 6 and north pole also 6 and south pole also 6, total 24 slots. Okay. So, we discussed with the help of the one story in previous classes. Okay. Now, let us assume what is this one? Back pitch. Back pitch is equal to pole pitch here. Okay, na? That pole pitch is equal to 6. So, that is equal to YF. Hence, YB is equal to 6 and YF also we take the 6. So, these are the 2 key points. Okay. So, based on this one, so we are going to calculate winding table. Okay. So, if you are having the any doubts here how the windings are distributed in 2 poles and 4th pole, so we will take elaborate with the help of the example. Okay. Now, you can see here. So, once again the calculations regarding this one, pole pitch is a 6 and m is equal to 2 and YB is equal pole pitch, that is equal to YB and YF is equal to 6. Now, in this case a number of the north pole, south pole, 2 pole machine, you can see round shape. Okay. How the slots are divided? Let us assume here it is a blue color north pole, south pole. Let us see. So, this is a 1 pole phase, you can see phase 1, this is a phase 2 and this is a phase 3. So, under influence of 1 pole here, you can see this is a 1 pole for example, and the same under influence of another pole, you are going to, so for example, this is a north, this is a south. So, this is a 1 phase, this is another phase, this is another phase. So, under 1 phase 2 slots are divided, m is equal to here, and another phase 2 slots, another phase 2 slots. Okay. So, remaining this is a 2 slots continuation, 2 slots, 2 slots. So, you can see R phase, Y phase, B phase, R phase, Y phase, B phase sequentially is distributed such a way that we distributed the given coils in the manner of distribution winding to produce the rotating magnetic field. Okay. So, now let us see the another 4 pole machine, how we are going to distribute these coils. So, before that one, here you can see the 3-phase winding, some one point you have to remember. Whereas, in case of single phase, what will happen? So, there is a phase, this is a phase, this is a neutral. So, whatever the current comes, and if you connected the load here, so it is simply will go. The phase displacement is the 180 degrees, phase and neutral. But in case of a 3-phase, so we know R phase, Y phase, B phase. So, here R phase, Y phase, B phase, we can phase sequence, we can represent this one, or we can represent the phase sequence as R, B, Y. So, this is another phase sequence. Anyway, phase sequence that should be, so this is a 3-phase, so 120 degrees apart. So, whether it's a R, B, Y. So, here the rotating in anti-clockwise direction. So, R, B, Y, or you can R, Y, B. So, you can show any phase sequence. Okay. So, but what will happen? So, the phase displacement between these two phases should be the 120 degrees apart. That should be maintained. So, this problem may not be raised in case of the single phase machine. Why? So, here you can observe that in any 3-phase winding, the total number of minimum slots that can be taken for pole for phase. So, 3-phase machines. So, there will be phase difference of 60 degrees between the two adjacent windings. If you are connected here, so for example, this one slot, slot number 1, slot number 2, slot number 3. So, second, for example, you place the R phase, here R phase, Y phase, for example, you can the B phase, here is we can the Y phase, for example, this phase sequence. Then what will happen? 3 slots. So, here, so this north pole under north pole, and 3 slots we have put the 180 degrees. Okay. Then each divided by 3. So, that means 60 degrees, 60 degrees and 60 degrees. So, what is the phase displacement between the two adjacent subsequent phases? Only 60 degrees. But in case of 3-phase, I require the 120 degrees. So, this is the logic. When the 3 windings start from the slot number 1, 2 and 3 here, but 3 phases, the phase angle between the 2 adjacent windings must be 120 degrees apart. This can be achieved by reversing the connection of the third winding. This is the third winding, and also taken the direction of the current in that winding is a reverse to the previous 2 phases. Okay. So, here instead of that one, so we can see this one, the 3 windings. Okay. So, here R phase, Y phase, R phase, B phase. So, as usual this phase sequence. Now, we take in this direction here. So, this phase 1, phase 2, phase 3, 120 degrees apart. Instead of going to this direction, so is as usual, so this direction. So, instead of the slot 1, slot 2, slot 3, here R phase we are going to place here, and this B phase instead of second slot you can place in this third slot. That means this 60 degrees and 60 degrees and 60 degrees. So, what is the phase displacement between R and B is 60 plus 60, 120 degrees we arrived. Okay, we arrived that thing such a way that, so we are going to connect. So, at the current direction in this direction, current direction this direction, in this case this current direction is the reverse direction, such a way that we are going to implement in 3-phase windings. Okay. This already we discussed in previous classes, dear students. Now, you can see this is another clarity how these slots or conductors distributed in a distributed winding in a given slots. Here let us assume here the poles are 4 poles, you can see, and slots are 24 slots. You can count these slots are the 1 to 3 slots and 3-phase winding. Okay. Now, in this case, so for example, the 4-pole machine. So, this is from this place to this place, let us assume this is a one pole influence, and so because M is equal to, so based on these calculations, that is equal OR phase 2 slots and another phase 2 slots, another phase 2 slots. This is under the north pole. Next, under the south pole, this 2, 2, so we are going to this one, this under the influence of this is the south pole, and under the influence of this one is the under north pole, and 1, 2, 3 the south pole. Such a way that, so this poles under south, under this conductors under the north, these conductors under the south, these conductors are the north. Now we can see these are the, for example, two phases, two slots are divided, allotted for the OR phase, two slots are divided for the Y phase, two slots are divided for the B phase. Such a way that we inserted the coil sides. Okay. So, such a we distributed the winding based on the our wave winding. Now, you can see here also, so two slots under the, this is a north pole OR phase and Y phase and B phase. Slot 1, 2 OR phase, 3 and 4 Y phase, and 5 and 6 is the B phase. Sequentially, you can say once again started this OR phase, another, so 7, 8, and this is the Y phase, 9, 10, this one, such a way that we connect. That means here we are going to connect the wave winding from this one. So, we are going to connect here, we are going to connect this one and connected this one and connected this one. So, starting and ending, we distributed OR phase. Similarly, if we are starting here, we can, this winding is inserted here and taking this one and going to this one, taking this one, going to this one, taking this one, this one. So, in this case, the winding connection should be given such a way that current is leaving here to create the 120 degrees apart. Whereas the B phase, you are going to start here and winding is connected and such a, this is going in this direction. This starting, this ending. We distributed the windings based on our wave winding. You can see one practical portion of how this coils inserted in a given slots. Okay. So, you can see this one, this is a one figure. Okay. So, this is the OR phase coils, this is the Y phase coils, this is the B phase coils, this is the armature slots. Dear students, you can observe that one. Okay. So, after knowing these basics, let us construct one distribution table as we discussed previous classes. So, what is the case study is given? The number of poles are 4 poles and slots are 24 slots. Let us prepare the one conductor distribution table. So, this is a conductor distribution table. So, what is here? So, this is under one pole, this is under one pole, this is under another pole, this is under another pole. So, 4 pole machine N1, S1, N2 and S2. So, under north N1, so how many slots? So, 6 slots, each phase 2 slots, you can see here. So, such a way that we connected 1 and 2 for the one phase, R phase, and 3 and 4 under the Y phase, and 5 and 6 under the B phase. Similarly, and 7 and 8 for again R phase, and here, so 9 and 10 for the Y phase, and 11 and 12 for the B phase. Such a way that, so we distributed the all slots under OR phase. What are the slots allotted? Number, you number the slots. So, what are the slots? So, 1 and 2 here north pole, and 7 and 8 under here, and 13 and 4 under here, and 19 and 20 under here. Total slots are 8 slots. That is enough. OR phase 8 slots is allocated and distributed in 4 pole machines in uniformly. Similarly, Y phase winding, that is also So 3, 4 here, and 9, 10 here, and 15, 16 here, and 21 and 22 here. Such a way that we distributed. Similarly, B phase also. This is a simple winding diagram, dear students. Okay, so how this slots, you can see one practical figure also. So this is the slots and coils, how the coils are inserted in a given slots with help of the insulating materials. Okay, so as you are already familiar with what are these slots, how the slots are distributed with windings. Okay, so now draw the winding table. So the conductor distribution table we found. The winding table, how we are going to draw the winding table. So as we know that winding table, so what is this one? So this is a winding table for phase 1, phase 3 and phase 2. Okay, so phase 3 is inserted in between the phase 1 and phase 2 to create 120 degrees apart. Now, so back pitch and front pitch, we know that both are how many? 6 and 6. Here is equal 6 and here is equal 6. Okay, so we will do manually. Okay, so now, so here phase 1, phase 3 and phase 2. Don't confuse the phase 3, not phase 2. Now, under phase 1, let us take the OR phase, Y phase and B phase. Now, under phase R1, so back pitch is equal to YB and front pitch is equal to here YF. So, what is the back pitch? Back pitch is equal to 6 and front pitch also 6. All are 6 and 6, 6, 6. Okay, let us do that one. Now, based on this one, so we will draw the one winding table for the one phase first of all. Okay, so now the start from the slot number 1. Start here at slot number 1 with conductor 1. Add the back pitch, we are going to connect 6, then 7th. So, we are going to connect 7th is the another pole pitch. Now, 7 plus 6, so we are going to get is a 13. So, here we are going to a wave winding. So, another north pole we are going to connect the 13th slot. Okay, so if you want to see that one, I started here and it's connected to the back pitch 7th. So, it is connected to the, so this is the north pole. Okay, so north pole, this south pole and this is the north pole once again. Okay, so this we connected the one pole pitch, so under the slots here. So, this is known as a 7th slot, 7th conductor. Now, it should be connected 7 plus 6. So, wave winding, it is connected to the 13th. So, where is this thing? This is a 13th. Now, we are going to connect 13th here. So, 13th should be connected where? So, 13 I am going to connect here. Okay, so 13 plus 6, 19th. So, I am going to connect, so where is the 19th? So, here I am going to connect it 19th. So, another 19th. So, 19th is going to connect where? So, 19 here, 19 plus 6, what is the value? I am going to get it 25. 25 means 24 slots, 24 minus 25, that is called 1, but already 1 is already engaged here. Dear students, please remember that. As usual, I connect the plus, then 19 plus 6, I am going to get the 25. So, 25, there is no number 25 slots, but is the 24 slots. So, 24, this is a 24 minus 25, that is equal to first slot. So, already the first slot is filled because the AC winding there is no closed circuits, closed winding path. Hence, so here you have to take the one precautions instead of this 6. So, you are going to get it one addition. Here you have to change the instead of 6, you have to change the 7. Why? So, please listen once again. If one side of the coil is placed in the slot number 1, the other side of the coil should be placed in the slot number 1 plus slot per pole, that is equal 1 plus 6, that is equal 7th. The finishing end of the coil side at slot number 7 is connected to the starting end of the coil side at slot number 13. We connected. Now the other side of the coil side at slot number 13 is placed at slot number 19. Adding 6 to slot number 19 gives the 25, which is slot number 1. But a coil side is already placed at slot number 1 here. So add 1 and place the coil side at slot number 2, because 1 and 2 belongs to the phase 1. So instead of here, so add the 6 plus 1, 7. Now 19 plus 7, we are going to get it, that is a 26. The 24 minus 26, we are going to get the 2. So 2 is the second slot, second conductor, which is belongs to the phase 1. Please keep in mind, dear students. Okay, so complete this, proceed the remaining part as usual. Okay, clear? Now it should be connected to the 2. Now 2 plus 6, 8. 8 is belongs to my slot. Now once again we are going to connect here. This should be connected to 8 here. Okay, now 8 plus, say here, 8 plus 6, that is equal to 14. Yes, 14 also my slots only. Going to connect here. Okay, the 14. Now what is that one? 14 plus 6. I am going to connect it. 14 plus 6, that is equal to, we are going to get the 20. So I am going to connect this 20. So here is a 20, here is the 20. So this is connected to 20. This is a finishing. Okay, so what is happened here? 2 slots, 2 slots, 2 slots and 2 slots. 8 slots. My quota is finished. So this is a phase 1 winding and wave winding. Okay, so now let us see the another phase. So here 3. Okay, so phase 3 here. So what are the slots we are allotted? So here, so 3 and 4 slots are allotted here. Okay, based on the distribution table. Okay, so what is the here distribution table? So first of all, start the third slot. 3 plus 6, that is equal to 9. We are going to the 9, and 9 plus 6, we are going to connect the 15th. Okay, so 15 plus 6, I am going to connect 21. Okay, here 21 plus 6, if you are connected, what will happen? That is equal to 27. So 27 means 24 minus 27, 3. Already 3 is engaged here. So we have to add 1 to the 6. Then we are going to get the 21 plus 7. So we are going to get is a 28. Okay, so 28 is nothing but 4. So you have to start once again 4th slot in the first north N1. Now as usual, so we are going to get it. So 4 plus 6, so 10, and 10 plus 6, 16, and 16 plus 6 is equal to 22. So this is a 22 is a finish, final. Okay, so as usual, dear students, so coming to the this phase, so what is happened here starting? So here 1 and 2 is over, 3 and 4 is a 5, 6. So we will start the 5th slot. 5 plus 6, we are going to get what is the value? So 11th. 11 plus 6, I am going to get it 17, and 17 plus 6, I am 23. Okay, 23 plus, now here we have to add it 7, that is equal to 30. 30 means 30 minus 24, we are going to the 6th slot. 5 and 6 is belongs to the phase 2. Now 6 plus 6, 12. 12 plus 6, 18. Now 18 plus 6, so 24, that is the final slot. So 24 is a finish. Okay, so these are the winding table, dear students. Only you have to remember, you have to allot, you have to enter only allotted slots for your cabin only. Okay, phase 1 2 slots, phase 2 2 slots, phase 3 2 slots, such as that we distributed conductors. Based on this one, we are going to take this YB and back bridge. Okay, so let us see with the animation. Now here start the phase 1. So start 1 plus 6, 7, and 7 plus 6, 13, 13 plus 6, 19, and here 19 plus, instead of 6 we are added the 1, that is equal, 19 plus 2 is equal, 7 is equal, that is the, we are going to the 26. The 26 minus 24, we are going to the 2. So that is the twisting point. After that, 2 plus 6 is equal 8, 8 plus 6 is equal 14, 14 plus 6 is equal 20. So 20 is a finishing conductor in last south S2 pole. Okay. Similarly, the phase 3. So here we alerted the slots. What are the slots we are alerted? So the slots are, we know that slot winding. Here 3, 4, 9, 10, 15, 16, 21, 22 slots are belongs to the phase 3. Okay. Now start the 3 slots. 3 plus 6, 9, 9 plus 6, 15, and 15 plus 6 is 21, 21 plus 7 is equal to 28. Here we added the 1, that is the 4th slot. And once again start it, 4 plus 6, 10, 10 plus 6 is 16, and 16 plus 6 is 22, and 22 is the finish. So you can see here what is the, as per our distribution table. So here 3 is completed, and 4 is also we completed. The 4th, where is this 4th? Okay, 9 we completed, and 10 also we completed. 15th we completed. Where is the 15th? So this is the 15th, and 16th, this 16th is completed. 21, where is the 21? So this is the 21 is completed, and finally 22, this is the 22. So 1, 2, 3, 4, 5, 6, 7, 8, 8 slots for phase 3 we completed. Okay. So dear students, this is the understanding purpose, I am repeating. Okay. So similarly you complete the phase 2. So in this case we started the phase under phase 2, that is a B phase. So 5, 6, 11, 12, 17, 18, 23, 24 slots are belongs to the this phase. Now start at 5th slot. So 5 plus 6, 11, 11 plus 6, 17, 17 plus 6, 23, 23 plus, instead of 6 we add the 7. So that is equal to 30. So 24 minus 30 is equal to 6. Now once again 6 plus 6 is a 12, 12 plus 6 is equal to 18, 18 plus 6 is a 24. This is a finishing. So we added, we covered 5th slots, 6th slots, 11th slot, 12th slot, 17th slots, 18 slots, and 23 and 24 slots. So dear students, so please listen here so carefully, and this table is very easy, similar to the lap winding, but so at twisting point you have to remember this one key point. After that, so you are going to implement as usual what is the wave winding with help of the back pitch and front pitch. Now after knowing this one, so what is the last step? That is the development of winding diagram with help of the winding table. So keep in mind this winding table site, and based on this one you connect the all conductors, the end connections. Okay, so let us do that one. So for development of the simple wave winding, so third step and final step is the develop winding diagram with the help of the winding table, just we have seen. So for this purpose, what to do? So as usual, we are going to draw the solid lines of equal length and equal distance equal to number of slots is given as per the data. Connect the coils as per this winding table and arbitrarily assume a particular current direction to the coil sides under the pole pairs. For the coil sides under the north pole region, assume downwards current direction and vice versa for the south pole regions in the figure. Okay. So now with the help of this winding table and this our line parallel lines, we are going to draw these things. Okay. So let us connect it. Okay. Here what has happened? First we started from this one. Okay. So what is the table? 1 plus 6. So let us take these colors also. So we take the red color for this one. So we take the R phase here, start here. So here 1, it is connected to the 7th. Where is 7? Here is 7. Okay. So we connected 7th is here. Now 7 plus 6 we are connected to the 13th. It should be connected here 7, 13th here. So we are going to connect, here is this one 13th. Now after 13th, so we are going to connect next after 13th we are going to the 19. Where is the 19? So this is the 19, this is the 13. So we are going to connect this 19. Okay. Then after 19, so we are going to connect second conductor. So this should be connected to the second. So it is entered once again from here, from 19th is entering. Okay. Second conductor. The second should be connected to the 8th conductor. So here 8th, this is 8th conductor. Okay. So 8th should be connected to where? That be 14th conductor. So this is connected to 14th conductor. The 14 is connected to where? So 20th final. This is the 20th conductor. Now this is a finishing conductor. Okay. This is a OR phase. So we connected based on the first conductor here start. This is the connector start here connected to 1 back pitch, that is connected to the 7th here, and 7th conductor front pitch we are going to connect the 7 plus 6, that is 13th. We are going to connect the 13th conductor, and back pitch 13 plus 6 is the 19th. Once again it is connected to the 19th back pitch, and front pitch we are going to the 19 plus 7, we are going to the second conductor. After second entering here, so second plus 6, the 8th conductor we are entered, and 8 plus 6 is the 14th. We are going to connect the 14th, sorry. So yes, 8 plus 6 is the 14th. We are going to connect the here this one. Okay. What is the 8th is connected to the 14th, and 14 is connected to the lastly 14 plus 6 is equal 28th. Okay. Such a way that we connect, this is the ending. So this is a starting, this is the ending conductor, this is R phase. Okay. Similarly, you connect the Y phase. So Y phase is started where? So here second slot is started here. Okay. So that is called third slot. You are going to connect the third, this is the third. So you have the drop dear students, you can connect carefully. So here is the our window is a small. Okay. So here, so 3 plus 6, 9, where is the 9? So here connect the 9th conductor here. 9 plus, you are going to connect the 6, that is the 15th. So you are going to connect the 15th conductor, and the 15th is connected to where? 21 conductor. So, this is a 21 conductor. The 21 is going to connect where? 21 is connected to the 4th conductor. Okay. So, this should be connected to the 4th. So, where is the 4th? This is the 4th. Okay, 4th, 1 second we came. This is a 4 plus 6, 10th. So, we are going to connect the 10th conductor here, this one, and 10th is connected to where? 10 plus, okay. So, 10 plus 6 is the 16th. We are going to connect the 16th conductor here, okay, 16th. 16 plus 6, 22, this is the finishing. So, this is the 22, this is the finishing conductor. But here, dear students, you can remember that you have to give the supply here, finishing here and leaving here. So, because 120 degrees phase angle we required. Okay. So, connection is here. So, current direction should be connected to this one. And coming to the another last phase, that is the B phase. So, here started from 5th slot, this is the 5th slot, you connect here, and this 5th is connected to 5 plus 6, 11. We are going to connect the 11th slot here, and 11 plus 6, 17. We are going to connect the 17 here. 17 is connected to 23. So, we are going to connect the 23 here. So, this 23 is going to connect where? That should be the 6th conductor. Now, this is the 6th conductor entered here, and 6 plus 6 the 12th conductor. We are going to connect the 6th here, and 6 is going to connect 6 plus 6 the 12th. Okay. So, that is us. We connected the 6 plus 6 12, and 12 plus 6 is the 18. Okay. So, we are going to connect, this should be connected to the 18th here, last conductor. The 18 plus 6 we are going to connect the 24. This is the last conductor. Okay. This is the finish. Such a way that you are going to connect. So, the current direction is starting, and the starting current direction is in this direction here in the two phases, but in this case reverse. Okay. So, now similar way you are going to connect in the connections. Very easy, dear students, if you know the winding table. Let us see in animation also. Let us say individual phase wise. Let us take the simple for easy understanding purpose. No need to separate each phases. For clarity of understanding purpose, I have made separate OR phase, Y phase, B phase. Finally, we combined 3 phases. Okay. So, based on the table diagram. So, in OR phase, what is happened? You can see. As usual, you connect it. So, here a slot 1 plus start at the 1, and 1 is connected to the 7, and 7 is also connected to the 7 plus 6 is the 13th, and 13 plus 6 is called 19th, and 19 plus 7 that should be connected to the second conductor. Okay. Now, enter the second 2, and 2 plus 6 8th conductor. Okay. Back pitch. What is the front pitch? 18 plus 6 is equal to 14, and 14 plus 6 is equal to, we are going to connect, that is the 20th. 20th the finishing conductor. So, this is the OR phase, dear students. Okay. There is no confusion, simple connections only, end connections. Okay. So, this is the back pitch YB, and this is the front pitch YF only. Okay. So, under 4 poles. Now, you can see the another phase, Y phase also. Y phase started from the third conductor. Start it. So, 3 plus 6 is a 9, 9 plus 6 is a 15, 15 plus 6 is equal to 21, and 21 plus 7 here, that is equal connection to the 4th. Okay. Now, enter the 4th here. Now, 4 plus 6 is equal to 10, 10 plus 6 is equal to 16th, and 16th plus 6 is equal to 22, and 22 is the finishing conductor, you can see here. Okay. This is a Y phase winding configuration. Similarly, B phase. So B started from the fifth slot. Start in the fifth conductor, and 5 plus 6 11. We are going to connect the back pitch. 11 plus 6 is the front pitch. 17. 17 plus 6 is equal to 23. So 23 plus 7, that is equal to sixth conductor. So you connect the sixth conductor. This is the sixth enter here, and 6 plus 6 is equal to 12. 12 plus 6 is equal to 18. 18 plus 6 is equal to 24, and 24 is the finishing conductor. These are the B phase configuration, dear students. Now combine this phase 1, phase 2, phase 3, okay, or YB. Now let us see. Same, this is the OR phase. Similarly, just you connect it. Okay, so here, so we are going to connect all these phases based on the winding table. Now coming to the phase 3, that is starting from the third slot. Third plus 6 is 9, 9 plus 6 is equal to 15, 15 plus 6 is 21, 21 plus 7 is equal to 4th. Okay, you have to connect the 4th, this is the 4th. Enter the 4th, 4 plus 6 is a 10, 10 plus 6 is a 16, and 16 plus 6 is equal to 22. That 22 is the finishing conductor. Okay, so this is the finishing conductor. Now the current direction here in this phase should be from here. It is a leaving here. That should be remembered. Next, another phase started from the 5th, and 5 plus 6 is equal to 11, 11 plus 6 is equal to 17, 17 plus 6 is equal to 23, 23 plus 7 is equal to, we have to enter the 6th. Now enter the 6, 6 plus 6 is 12, 12 plus 6 is equal to 18, 18 plus 6 is equal to, so 24th is the last conductor. These are the total winding diagram required as per a given question, dear students. Okay, very simple. Okay, so this is a no need of the slot positions, and that is the commutators, brushes in case of AC. Okay, this is the final winding diagram, dear students. Now where we are going to use this type of the winding? Okay, as we know that AC windings are generally used in different machines used in our electrical engineering system. Okay, now this winding can be used where? So we can use in different fields of electrical engineering. So you can let us see, this is a winding. So whatever you done, that is in the form of physical. You can see how this winding are connected in a given armature winding. Okay, so this is the final winding, dear students. So this completed total electrical windings, dear students. What we have seen in this class, let us conclude once again. We have seen first what is the windings, what are the different terminology regarding to the windings. What is the back pitch, what is the front pitch, what is the slat pitch, what is the full pitch coils, what is the pole pitch. We have learned all basic terminology regarding to the winding table. Next, we have seen that how we are going to develop lap winding and wave winding in single layer and double layer in DC machines, and how we are connected the commutator segments, equalizer links, and how we are placed the brush positions in the commutator segments. Next, we have seen the AC windings comparing to the DC, and OC windings we have seen first in the AC single phase. Now we are drawn lap winding and wave winding in single phase AC motors. Next, we have seen three phase motors, compared AC single phase and three phase motors. So three phase motors are very important and efficient comparing to the single phase motors. Then we preferred three phase motors, how the winding is wound in a three phase commutator segments, sorry, in the slots, armature segments. In armature, so we also provided the three phase lap winding, three phase wave winding. So based on the back pitch, front pitch, some assumptions. Okay, so these are the total windings, dear students. So easy to draw in drawing sheets with help of drafters. For understanding purpose, I have used different colors in my laptop, but no need to draw these colors, just use the pencils. Draw neatly, completely. Okay, thank you for listening my class, dear students.